Hello, everybody, and welcome to another episode of Learn with Jason. Today on the show, we have Shruti Kapoor. Thank you so much for joining us.
Thank you for having me, Jason.
Did you see my overlay just tweak out? That was great. It was like the whole thing
Yep.
just forgot that we were playing. Um, so it's great to see you. I'm very, very happy to have you on the show. It looks like the chat is also very excited. They're booping the hell out of us. What's up, chat?
I
Good to
love
see
the
you.
boops.
Oh boy, we were starting it off strong with a subscription. Thank you, Emalu. Really appreciate that. Okay, so Shruti, I know you. We both spoke at React India together, and it was a lot of fun. And I feel like what I've always appreciated about you is you've got a great sense of humor. You run the dev jokes hashtag that always makes me smile. So for those of us who aren't familiar with you and your work, could you give us a little bit of a background and like maybe a joke?
Sure.
Okay.
Hey, everyone. I am Shruti Kapoor. I am a senior software engineer at PayPal. I've been at PayPal for 2 years. I live in the Bay Area. I've been in the Bay Area for like 4 years now. Um, some things about me, I love GraphQL, JavaScript, React, but more than that, I love dev jokes. So I'm going to give you my first dev joke. Okay, so you guys can answer in the chat as well, and I'll be reading the chat. So the first question is, why do fish like React? Why do fish don't like React?
Why do fish not like React? What do you think, chat? Oh, no ideas from chat. I think. Oh, because it has hooks. Did the chat get it?
That is right. You're right.
I love it. That's excellent. Hey, what's up? I see Kenzie Dodds is in the chat. Cassie Codes, Sia's in there. Sam, what's up, everybody? It's great to see y'all. Thank you so much for coming to hang out with us today. All right, so Shruti, I'm really excited about this because today we're going to do something a little bit different than the usual Learn with Jason episode. So what I thought would be really interesting is you're at PayPal and you're working on like massive. I mean, everybody's using PayPal, right? So we've seen the scale of PayPal. We know that it's a huge enterprise app, and I thought it would be really interesting to talk about architecture, right? And to dig into kind of how all of these things that someone like me, who I mostly work on my personal website, I mostly work on like projects that are a little smaller. I have all these ideas. I love GraphQL. I love Jamstack. I wanted to talk about it in the context of something bigger, something more ambitious, and like how do these ideas apply to the largest possible scale? And that's where you come in because you have so much experience in that. And so like what is your I guess what are you working on now, and like what are you excited about in your work?
Yeah, I am working in the PayPal payouts team. I see Gary from my team. Hi, Gary. I'm working in the PayPal payouts team. So basically, payouts is the product that helps PayPal mass disperse money onto accounts. So the stack that we're working on is Node.js on the front end with React, and on the back end we have Java. So in PayPal, typically we have this kind of stack. We'll have a microservice architecture, and then we'll have Java in the backend, which creates REST APIs, and we have GraphQL APIs, which gets consumed by maybe an orchestration layer, or maybe there's a GraphQL API itself. And on the front end side, that data is rendered via React components
Mhm.
through a Node app.
Okay, yeah. And so when you're like, what is your vision for this? Like as it's growing, it sounds like you're starting to explore some alternatives.
Yeah. So I think the main problem that we are, or the main challenge that we're exploring is how can we reduce the time it takes to render our first page or our first component to the user. So how can we reduce that latency that the user sees?
Hmm.
And that's where I've been exploring how Jamstack can help us, especially Jamstack with GraphQL. Because with GraphQL already you're getting less data to the client, so you're shipping less data, and
Hmm.
that reduces the number of bytes they have to download. But then also with Jamstack, you can actually reduce the time that it takes to actually load that first component. And that's where Jamstack and GraphQL combination kind of comes in. That's what I've been exploring and experimenting with these days.
Very cool. Okay, so so let's do a couple things here. I'm gonna switch over into a collaborative view so that we can start. We're gonna use Mural today so that we can kind of draw and do architecture and notes and stuff. And then I'm gonna also do a quick shout out to our sponsors. So we have live captioning today, as always, by White Coat Captioning. So huge shout out to them for making this possible for us. Boy, come on, little overlay, you can load. I believe in you. Come on, there you go. I think my overlay is taking its sweet time loading today. So yeah, here's Shruti's Twitter. You should definitely go follow her for lots of information and also lots of good jokes. And then if you want to get live captioning, it is, let me refresh the page here. Live captioning is happening right now by White Coat Captioning, and that is made possible by our sponsors, Netlify, Fauna, Sanity, and Auth0, who are all kicking in to make the show more accessible to more people. So thank you very, very much to both White Coat Captioning and our sponsors for doing that. And with that, we have a mural that we've set up that we're going to use. And if you want to follow along, I really hope, let's see, visitor link. We don't want... So I don't know. It's not that I don't trust you, Chad. It's just that I don't trust you at all. So what we're going to do...
dialogue, trust them, but don't trust the devils inside them.
That was way deeper than I think the usual information on this. Like, trust them, but don't trust the devils inside of them. That... All right, I'm taking it. I love that. So what we are doing today is we're going to talk a little bit about architecture. And so if we maybe we should start by framing what a typical architecture looks like. So if we look at, like, I think I can do some shapes here. Let's do some shapes. And I'm going to make, let's start with like some big boxes. So we'll start with a big blue box, and we'll call this the front end, if I can spell it. And so, like, the front end of a site is going to sit up here somewhere. And then you're going to have your, oh boy, where am I going? I haven't used this tool in a while, so I got to get my bearings again. And then you've got the back end of your site. And these are kind of like, sort of, I don't know, how would you kind of define these if you were going to break them up? Like, what goes into each thing? Or, like, are they even separate things? Am I getting presumptuous?
Yeah, question of the century, right? Like, where do you stop the front end? Where do you stop the back end? So let's say that front end is the HTML pages that the user sees. Kind of getting into the box of backend with Node.js architecture. And then Java kind of is very backend, which may have like REST API or GraphQL endpoints. So we can have HTML pages at the top, which would be front end, and then we have the layer in between that serves up those front end pages using React and Node.js. And then we have the system that serves that data, which could be your Java layer or Python. And then we have the backend, like the databases itself.
Okay, so you're saying, like, we've got so you, like, maybe we could big bucket this into like business logic as like the back end. And then we have, I'm making these a little bit smaller so we can fit them all on the same page. This isn't me trying to play favorites for front end. So we've got our business logic, and then we have our actual, like, databases.
Yeah,
Like
databases and the layer that serves that interface between databases and business logic.
anything the user receives is front end. Okay, I got you. Yeah, I think I think that's correct. So yeah, like I guess we're trying to think of like the big things, right? So when you've got the stuff that goes to the client, you've got the way that the client gets information. So like a API layer or however, data or
However, that data is surfaced.
and then you've got your business logic, which is the stuff under the hood that would do things like, let's determine whether or not someone is allowed to see this data. Let's do some pre-processing to, take some raw figures and turn them into something a little more human readable. Let's aggregate data from like our different things to show them on an analytics dashboard. And then under the hood, you've got that actual raw data. So your user tables, your log dumps from whatever app, all your usage stats and payment information and all those things that kind of, they're not super useful if you just look at them in aggregate because it's a giant pool of information. You need something to pull that out and kind of collate it. And so this is, I feel like we're probably oversimplifying a little bit here, but for the purposes of having a discussion, I feel like these are like big buckets that we can agree kind of that seems about right. Anyone disagree, chat? Are we missing anything big here?
A sandwich with bread in the middle called cake.
Asking the hard questions in the chat, I see.
Sandwich with bread in the middle. That sounds like a cake to me.
I mean, a sandwich with bread in the middle is just a club sandwich, right? Yeah. So I think like if we look at this from a classical kind of like the monolithic standpoint, you might just like draw. Let's see, where am I? Oh, I was on this one. You might actually just draw like a big square around this whole thing and say like, this is the monolith. And when you do, look at it helping me with my monolith. And I wanted to draw it instead of typing it because it makes me laugh. So this is like our monolith, right? We've got this big kind of everything lives in one place. And this, I think, was a pretty standard approach for a long time. It still is a standard approach in a lot of places where, you're going to talk to your database and do the business logic and prep the data and expose the markup and front end all in the same place, right? And so is that that's not what you're doing right now, right? You're doing something different.
Yeah, so we don't have monolith. We have more like microservices. So we can think of this as breaking down the front end in the API layer and the business logic. So take this big monolith, break it down into smaller components. They all talk to databases. They may have different tables. They may be talking to the same tables. So we can think of as like smaller architecture components within itself.
And so this would almost look like if you take your business logic and you do something like this, where you've got multiple services that all kind of have the same stack. And then your front end says like, hey, or actually even the front end could be part of the microservice. Is that how you're doing it now?
Yeah, exactly. Even the front end is part of a microservice. To the user, everything looks like a single front end, but inside it's all smaller components serving up their own front end.
Yeah. And so something like this, this could be like, I
was just going to say, they could be like completely different stack in itself, the front end itself. Mm-hmm.
And then you end up with something like, you've got your users and your dashboard and your billing, or however you want to do that, where each of these is a whole different thing, and like maybe like you said, a different stack. So maybe this one is we got a front end and it is React, and then with this one maybe
Could be like
it's
Backbone.
and then
The third one could be like Angular.
totally. And then like this one is going to be, let's say, a REST API, and this one is going to be, direct MySQL connection. And like maybe this one is like just out to make you sad and it's soap, right? Something like that. So you kind of end up with like lots of different ways that you could do this, and then this one's maybe built in like something like Rust, and this one is PHP, and this one's Java, right? So you've got all these kind of interesting ways that you could approach these things that like the teams don't necessarily need to talk. And this is what makes microservices really exciting, is now you're instead of saying like everybody's working in the same code base, you've split things up into their concerns. Like this is the user's team, and as long as they make sure that the user's route looks right and works, then they kind of don't have to care what the dashboard team is doing. They don't have to care about tech choices.
Exactly.
But so
It
like,
brings
where does
that
this?
separation of concern.
Yeah. So like, are we, when you look at something like this, like, are we done? Is this, where are the issues that come up with something like this, do you think?
Yeah, so the issue kind of depends on in this box, in the API layer box, how much data are we serving to the front end, right? So business logic, let's say that in databases, we have some information that we want to serve up all the way to the front end, right? So how much information are we pulling from the database, and how much of that are we serving up? That is determined by the API layer, or let's say the business logic. So both of them combined. So that's one place where we have a place where we can optimize and reduce the data that we send. And then on the front end itself, like how much data are we shipping to the users the first time they load the page? Is that data all necessary? That's another place where we can bring in performance and reduce the time it takes to load the first paint, make the first paint.
Yeah. Well, and so I think like this is the other issue that we ran into like when I was at IBM is what we've drawn here is really clean. We're saying that like each team has a very clear stack, right? But what I found when I was at IBM is that it's never actually like that. It was more like, if we take this over here, we had I'm going to simplify this a little bit. So let's say that like these orange ones are microservices. So we had a users microservice, we had a billing microservice, we had an apps microservice, and these all live down here. And then on our front end, and I'm just going to kind of assume that each one of these has some kind of an API on the front of it. And then on our front end, we would have like dashboard. And now dashboard didn't just use users. It also used, why can't I need this. Get out of here. Oh boy. I haven't used this in so long, sorry. But so, we end up with something like this where like dashboard has to touch all of these services. And then we have to, like we've got to make this work. So we have a different REST endpoint that we're hitting to pull users, and then billing, and then apps. And before we know it, we are suddenly building like a proxy API. And this proxy API is how we're able to talk to those services. And now we've got a huge problem. And like, have you run into this? Do you want to talk to this a little bit?
Yeah, exactly. So this happens all the time, right? Dashboard may want to have access to users, so would billing, and so would all the other components, right? So especially in an app like PayPal, most of the flows are authenticated. You have to log in to see everything. So everybody needs access to users. So what ends up happening is that everybody starts calling users. And then based on like billing gets called a lot, and maybe there's an authentication service that gets called a lot. So instead of the ideal model that we had at the top, everybody starts calling every other service, or like one service gets called multiple times. So this
Mm-hmm.
happens quite often.
And what we found too with like on my team, the dashboard. So like the dashboard would have a different need. So for billing, it would only pull a few things, right? But it came from a few different places. So there was like a REST endpoint for billing that was specifically for the dashboard. They built like a bespoke endpoint. And these were two different teams. So there was a dashboard microservice that actually showed the dashboard. And then there was like a billing microservice. And these teams, one team was in China and one team was in Toronto. And so for those teams to work together, they had to like write up a spec and then send it back and forth. And then the backend team made some changes, and then they would ship their REST endpoint, and like then the dashboard team would use that. But then the billing team, they needed a bunch of information from billing, so they had to do the same thing. They wrote up a spec, billing wrote up this custom endpoint, and now billing had 30, 40, 50 bespoke endpoints that each service needed to use, and there was no way to validate whether or not any of them were still in use. We couldn't sunset things. We couldn't remove data. There was no visibility into what was going on, right? And so it was growing out of control. We were like, I don't know, does stuff break? I guess let's just turn it off in staging and see if anybody calls us.
Yeah, that happens all the time, right? Like that's why we have versioning in API. So like we don't know if this field is being used or not. So instead of removing a field in this version, let's create another version of the API. So we have V2 and V3, and at some point we have like V150 and so on. Right? So we are in that versioning hell.
Yeah, and it's like the worst. And it just creates all this pain, right? Where the back end teams are frustrated because they feel like the front end teams aren't like the front end teams just ask for whatever they need. So it feels very much like getting yanked around. Front end's like, well, we need to show this now, so you need to give us a new endpoint. Front end is frustrated because they're like, well, we know this data exists, but we don't want to have to call 50 REST APIs to load the data that we need because that's super slow. And whenever they end up doing that, that's how you end up with these proxy APIs where you're like, I'm going to call a bunch of APIs and then I'm going to do business logic on my front end to assemble this data into something I can use. And then my front end's going to call my change data. And so now you've got these like links in the chain and they're all really fragile. Your front end's calling a custom API. Your custom API is calling a bunch of custom APIs. And those are all hooked up to databases that, they don't really know what you're doing or how you're using it. So they might just accidentally break it at any point. And then when it breaks, you have no idea how. Like, there's so many hops, right? Like, how do you debug that?
And sometimes what happens is like you have these multi-layers of proxy APIs. You have like users that's being called by everything upstream. And then the upstream service itself is calling 5 other downstream services. So you have like this layers of APIs being called, multiple downstreams.
Mm-hmm. Yeah. And I think that this is, so this is, I think, something that if you've worked at a big company, you may be familiar with this. This may look like something that you've dealt with before. So we're not here to just talk crap. We're here to show like maybe what's better. So if you were going to try to sort this out, how do you untangle this? How do you do it?
Yeah, so the first thing I would start looking into is when we call this proxy API, which service are we calling, right? Are we calling users like 3 times? Are we calling billing in apps? And then let's see here, right? So billing is also calling billing in apps. So that looks like that one common service is being called everywhere. So there is some place we can optimize there. Also, if we have like users being called by dashboard and users is being called by billing, we need to make sure that the data that we surface in dashboard and the data that we surface in billing is sufficient enough for both of them. So we shouldn't be like creating multiple endpoints every time we have a new customer, which is typically what we have to do in REST. So what happens is like we'll have this file where we have a bunch of different endpoints, and then what ends up happening is some of those endpoints are not getting used anymore.
Mm-hmm. Yeah. And so if we want to fix that, like if we just kind of imagine a perfect world, right? So let's take this over here and let's just imagine a way to make this all better. So I'm going to take these arrows out, and I'm going to take this proxy API out, because those are the things that make us sad. So let's show something that would make us happy. And I'm going to take this, bring it over here, and let's just say like, no, I don't want, come on, Mural. Oh my God, stop. Why? Hello? Okay. Unified data layer, right? And so then what we get with a unified data layer is we have now something in between where when we take this, like our communication now becomes completely, wait, you're supposed to be copying right now. There you go. It becomes like very clear cut. We've got this is what we're doing with our, this is going to be we should have used Excalidraw, I think. I saw that come up in chat, and I the only reason I didn't is because I don't think Excalidraw is multiplayer. And I wanted Shruti to be able to make changes in here. But so if we look at this, like now each of these, the dashboard is going to call the unified data layer and say, give me everything I need about users, billing, and apps. And the billing is going to do the same thing. And then the unified data layer just knows in the back how to get to users, billing, and apps. And so this creates, there are several things that are going to happen here. And this is why it's important. Now, the apps team, they don't have to worry about the 13, 14, 15 front-end services that call their layer. They only have to worry about this one. This is what they test. This is what they have to validate. This is the team they have to notify whenever something's going to change. And these teams, when they need to find data, they don't have to try to hunt down which microservice provides the data that they want, because they know that all of the data is here. And so this is like extremely exciting in my opinion.
Exactly. So it's like one place where everybody can come and talk to them. They don't need to worry about anything that goes downstream.
Hello to the corgis. Yeah. Oh, and thank you for the sub, Jordan. I appreciate that. It's always great to get a corgi storm. So Shruti, you were saying.
What was I saying?
We were talking about the unified data layers.
The corgis. So there is this one place that everybody can come and talk to, and then anything below that, so it's kind of like a black box, right? Anything that goes below that, you as a front-end developer or the team that writes the dashboard application doesn't need to worry about it. So the unified data layer team or the team that owns that component can take care of that, call users and billing, and do their own performance optimizations to make like one call instead of doing multiple calls to those APIs. So you're kind of now separating the concern of performance on the back end and performance on the front end.
Mm-hmm. And the other thing that's exciting about it too, that I think is so powerful, is like when we're talking about like any API design, monoliths are very exciting when it's, when you're trying to just build something, because it's like, well, everything's in one place. I'm trying to limit the cognitive overhead and limit the amount of things that I have to keep in my head. But as you scale, having everything in one place, like you can't track a million lines of code. You can't keep that context in your head. So then you start to cognitively, shift. You're like, okay, well, the easiest way to keep track of this is to break it into pieces that are small enough that I can keep the context in my head. And so you go to microservices. Exactly. And then you have a smaller number of lines of code. But the problem is you don't eliminate that context. You still need to know how the microservices interact with every other microservice, because there's so much interdependency. You've created this, like, it's a strong tie between microservices, and that means that you haven't actually eliminated the context. You've just spread the code out. Mm-hmm. You go this way, you get to this unified data layer, you've eliminated context. You no longer need to know how everything else uses the data, because you're not the person, you're not the service providing that data. You are giving that data to a single place. You've created a very clear boundary between your microservice and everything else. And as long as you honor whatever that single contract is between your service and the unified data layer, that's all the context you need. And that is so powerful.
Exactly.
But yeah, so if we want to make this unified data layer, how would you do it?
So this is a perfect place for GraphQL. GraphQL is this unified data layer where you establish a contract with the backend folks and the front end folks and decide upfront what data needs to be surfaced. And you're not tied just to doing this upfront. You can also, as you go through the progress through the project, if you have new data that you need to add, you can add it to the schema. And one thing that GraphQL is really good at is providing you ability to see which fields are being used. And you can know exactly what field is being used and not just like what method is being used. So that's really helpful. And that helps in, like, let's say you have users and you have 5 different fields that are not being used anymore. You can mark them as deprecated, and that can go that you can remove in the next phase. But any client would, if they were using that deprecated field, they would know that this field is going to go away. So you know that this field is not being used. You have data on it that you can see, you can monitor it, and you can remove that field if need be, instead of like blindly versioning it or blindly removing that field.
And what I like about it too is it creates like a fuzzy upgrade, as opposed to these like hard V2, like we're shutting off V2 on this date and you have to migrate all your endpoints. It's like, well, no, everything's going to keep working. This field is just going to start returning null. So like your code will still work. You'll just be missing that data unless you start using the updated field.
Exactly. So it's backward compatible to people or to applications that have already interfaced and started working with the APIs.
Yeah. And it's just, I love it. And this was something that we noticed at when I was trying to roll it out on my team, and it sounds like you've been finding the same, is like by putting this layer in, we're eliminating just a tremendous amount of cognitive complexity. So when a team is using something like, and I think it's worth maybe at this point looking at some of the things that make GraphQL exciting. And I'm trying to think of a good example. Let's go to how to GraphQL. And so how to GraphQL, do they have a playground in here that we can look at? I feel like they did at one point. I'm not sure if it's still around. Oh no.
Doesn't GraphQL itself have it? Let me see.
Well, actually, here's one that I know exists. Let's go to the Rick and Morty API. And there is a GraphQL Rick and Morty API that we can look at. Okay, so I want to show you something really cool just right out of the gate. So check this out. So we've got the REST API and the regular API. So I'm going to click this. This is what you get when you go to a REST API. We have gotten our basic documentation. We've got the characters, we've got the locations, and the episode. So it tells us where to go, but it's not super helpful, right? So I got to click in here. I got to look through here, and I can see sort of what's going on. But look what happens when I pull up the GraphQL API. I'm looking at a UI, right? And if I open this, I can see the schema, and we can see, all right, this is pretty computery. I don't know if this is super helpful to me, but like, let's look at the docs. Okay, this is interesting. I can see a character. I can see that the character is going to give me an ID and a name and things like that. Okay, so I can just try this. I can go in and I can say I want a character, and like they've already built a query for us, so we can look at what's going on. And so I can just play. And notice that, like, remember when we were here, we were looking at characters. So here's a character, and let's just pull one of these up. Okay, so here is one character, and let's see, his URL is, I think, if we just go to like character 1, yeah, here's 1. All right, so then what we get back is like an episode, and the episode includes like a link. It's not actually information. And then if we go down to the URL, okay, that's kind of useful. But what about like the location? Okay, the location is Earth, but there's just a URL to it. Whereas in here, I'm able to get like, here's the location, here's the name, here's what dimension it's in, here's an image. Let's pull up episodes. So I'm going to look at episodes, and then inside of this, I can see the name, I can see what date it aired. So instead of like having to make chained REST API calls, I can just dig through this to figure out what's there, and I get all of that data back. And I didn't need to go read the docs for that. I was able to just look at these embedded API docs to figure out that there was stuff that I wanted here. I could go see, all right, here's the episode, and I want this information. And I can test these queries, and if I want to use this in my app, I can literally copy paste that into my code, and it just works. So this, as a front-end developer, changed everything for me.
Yeah. And what's cool is like they didn't have to build this documentation themselves, like by writing it down, this automatically gets generated for you. So that's super helpful. So it's something that happens in the background. So I don't have to consciously think about writing documentation that's up to date. And
it's really, really cool. And then if we go and look at, let's look at how to GraphQL again. So we can dig into some of the basics. I think we can see, I just want to see, yeah, here's a GraphQL type. So I'm able to just say like, I want my data to have people in it, and I want a person to have a name and an age. And I know that that's required, which is why I've got this exclamation point. And this one's going to be a string. This one's going to be an integer. This is, I mean, it's not exactly human readable, but it's more human readable to me than a lot of code. Where I can sort of deduce what things are. Like, I know what a type is, I know what a person is, and as I kind of look around, I can mostly figure out what this stuff means. And then you can see that we start linking things together. So we've got a person, and that person writes posts, and when you search for posts, you get an array of this post type that's up here. So we can start to see how this all links together. We get this web. And this is the definition that I would write to make a GraphQL API. And then that definition gets read in here, right? So here are the actual types for the characters, for episodes, and all those things. So when I look at a character, I can see that I'll get an array of episodes back. And I know that that's going to have this data. So when I go in to look at here, here's my episode, and here's what comes back with it. Like this all, it's very logical. And that allows you to do things like autocomplete. Like I'm hitting control space and it pulls up all of the available fields because it's explorable like that. And this is just compared to using something like REST. Like you can do this with REST, you absolutely can, but you can't not do this with GraphQL. Whereas with REST, there's a bunch of extra tools you have to add.
And you get it for free, right? So you don't have to put in extra effort for that.
Yeah, it's like, it's truly, this to me is extremely exciting. And I think that it's like, it just opens a lot of doors. And then, so now we're talking about it from the front end, right? So from the front end side, this is kind of a dream because I, as a dashboard developer, I'm just going to go to mycompany.com/GraphQL and I get this explorable API. I'm going to, and we can do authentication. So I'm going to send like my authentication token that says I'm authorized to read from this data. And now I can just explore the whole database of the entire company and see all of the data from all of the microservices and build the custom query I need to pull just what I'm going to use. And then I get to build my UI with it. That's amazing.
And cool thing is like you need to pass in that JSON, authentication token once, right? So what happens usually is that if you have 5 services, you'll have to pass that token multiple times. But with GraphQL, because you have this one place you're talking to, you only need to pass your token once.
Yeah, and like just so much complexity disappears, right? Actually, I have a very good example of this. I don't know if every once in a while Sean Grove is on the call. I don't know if he's here right now, but I'm gonna show off his product for a minute. So this is a let me see. Yeah. So this is like a product called OneGraph, which is just kind of a nice GraphQL interface. But it does this really interesting thing where look at all of these services, right? So this is Airtable, Box. We've got Egghead, Dribble, MailChimp, all sorts of stuff is in here. And as a user, I want to be able to just like pull some stuff together. So I'm in this Explorer tab. So let's pull up some information about me. Let's pull up my Twitch. Twitch is going to make me do some weird stuff. Let's do some different stuff. Let's get GitHub. That's an easy one. So I'm going to get my
And
GitHub,
Twitter.
and I can pull in like my meta, or I want repository. Let's pull up any repository, and okay, they pulled one up for me. Okay, well look, now I need to log into GitHub, so I just click this button. I'm now logged into GitHub. I can run this call, and I'm pulling in information about GraphQL. And then if I go to this like me tab, I can do some just like, and I'm not showing this to show off one graph. I'm showing this to show off the power of GraphQL, because all of this information is a single GraphQL layer. So when I'm in here, I'm pulling up like my GitHub information. I can get my avatar URL, my bio, and let's pull up my, I don't know, like my login.
Profile, is there a profile picture?
So got that. And then if I want to pull up my Netlify, I can pull up my my full name, right? And I can probably pull some extra stuff, but I won't. And so now I need to log into Netlify. Okay, I'm logged into Netlify, and now I can pull this up and like just check this out. So I'm now pulling data from GitHub and Netlify in a single API call. And so these are completely different companies. They're not. This isn't like microservices in a team. This is like completely separate entities. And we still get this unified API experience where it's explorable. I can just click around and decide a thing I want and click into it and get it.
Yeah, and they all may not even be GraphQL APIs. They could all probably be REST APIs or a combination of GraphQL or REST API. They don't have to be a GraphQL or a single type of API.
Exactly. I mean, it's exactly that, right? And I think it's just it's unbelievably cool how powerful this stuff is, because GraphQL is just an abstraction over the top of data that makes it easier for front ends to get to that data. And that means that, we're able to, here we are, we're logged in. It looks like I'm logged in as my Twitch bot, not as me, but I have access to like 3 completely separate data sources, and all I had to do was provide the tokens, and those tokens are in here. You can see which ones you're logged into. But like when you look at an enterprise service, this is the most enterprise thing I can imagine, is like, how do we string together completely different companies as opposed to teams? Because you're not going to get GitHub to communicate with OneGraph to provide data. You're not going to get Netlify and Twitch to talk to each other to determine whether or not the data that they're sending is the right data. This GraphQL layer removes the need for that entirely. Mm-hmm. I, as a front-end developer, can just go and look at this one thing, and I will never speak to people who work on the teams behind this data, most likely. But I can still use it. I can still access it. And so we can take that idea and we can roll that into our enterprise apps. And now we've created not like a separation, like, oh, front end and back end should never mix. They don't need to communicate, but we eliminate the noise of like, well, I need a bespoke endpoint. I need you to update this thing so that I can make my front end different, or you need to change the front end so that we can fix this problem in the back end. All of that like back and forth goes away. And instead you can talk about what would make our product better. What can we build, and how could you use it, as opposed to please fix our problems.
Exactly.
Okay. So I feel like the GraphQL side of things is super, super exciting, and it opens up a huge amount of doors. What are the tricky, like what's the other half of this, right? So let's go back in here and let's think about like, how can we make this better if we wanted to take it further?
Yeah, so let's see where we are. We have figured out a unified data layer. So we're going to make it GraphQL. So that means we're going to fetch less data, right? Mm-hmm. Now, the question is, we still have these separate apps. So let's maybe dive into the architecture of these apps, see what they are.
Yeah.
So typically, let's see, we had this at the top. We had a node layer, I believe. We haven't dived, we didn't look into the front end
We
there.
haven't
So
really
let's
looked at
do
the
that.
front end. Okay.
Let's do that.
Do you want me to do it, or do you
How
want
front
to?
end works. You can do it.
Okay.
You're the pro.
So, yeah, I'm a mural pro. I've been using it for a whole 18 minutes. I'm ready. So let's expand one of these out, and let's think about what goes into this billing service. I just realized I think I've had coffee in my mustache for like this whole show, and that is gross. Sorry. I hope that that wasn't like visible in the video.
I don't think anybody noticed until you said it.
Okay. So inside of this, we're gonna need like we've got our actual like what goes into the front end code. So the HTML, CSS, and client side JS that goes in here. And so this is going to be something like maybe React, Vue, Angular, whatever. Any front end that you want to use is gonna be part of this. And then you also have your like data loading, right? And so this would be like maybe it's well, okay, so we should probably talk about this in a couple ways, right? Because we can do this a few ways. There's going to be something that serves.
Yeah, your web app.
Right. So we've got a server, and then we also have a like data connection. And then like thing that calls the API.
Yeah. And this is what connects to the GraphQL unified layer.
To the unified data layer. Okay. So all of that lives inside of this like billing bubble, right? And so I'm going to put these side by side so that they don't like overlap, but basically this is one front end. And so we need to answer these questions, and we can do these a bunch of ways. So the typical way that you would end up doing this is through some kind of like Node, PHP, Java, whatever. Like you're going to have some kind of running server that when a request comes in, you're going to determine how to handle that and return the appropriate front end files.
Yep.
So that's good in a lot of ways. Like we can do things like if billing comes in with parameters, we've got, user project or something like that, where we can pull in this URL and say, okay, when somebody hits the billing route, we want to send it to this server. That server says, okay, well, what's the user ID from the URL? What's the project ID from the URL? Send off the request to get that data, and then send me back the data that I need, and then it builds the HTML, CSS, JavaScript, and sends that to the browser. That's good. Like it does the job.
Yeah.
Well, so what are the challenges here?
One good thing that I also wanted to mention is that because you have access and control over the server, let's say if you want to show multiple, like for example, you want to do A/B testing, you know what user it is. Now, because you have control over how you render that HTML, because that's built on the fly, you can do A/B testing very easily, right? So for user A, you show A page, user B, you show B flow. And so on the server side, you can control which flow you want to show to which user.
Yeah, and you would end up doing that through what, like cookies or sessions or something. Yeah, you can do it a bunch of ways.
Yeah, exactly.
So the challenges to this, like where have you seen this start to break down?
Yeah, so the challenge is, let's say that you have, let's say we fix the data that we're pulling. We're always pulling constant amount of data. We've fixed our backend layer, so our backend is not a bottleneck anymore. Every time the user requests a page, we have to rebuild our HTML because we only have React on the server side, right? So we have React components. We're going to build HTML on demand, really. So that slows down the time it takes to completely render the whole page. and make the web app usable.
Yeah. And so we're basically like, instead of just someone being able to say, I would like this page, and here's your page, it's, I would like this page. And it's like, which page is that? Okay, let me go ask the server. Okay, server, you go ask the database. Okay, let's show them that page.
Yeah, and then let me finish building this, let me finish rendering this, and now I'm ready to give it to you.
Yeah. Yes.
And then most times, like let's say if we have this billing app, right? Most times the user is requesting the same page, or most users requesting the same page over and over again. Maybe one or two fields would change, but usually it's the same skeleton over and over again that most users are fetching for. So we are building the same kind of page multiple times for multiple users.
Yeah. And that's like, this I think is extremely common, where you find yourself kind of 90% of the app is always going to, the header's going to look the same. You're just going to swap out the avatar and their name. The billing page, all of the UI is going to look the same. You're just swapping out the data in the chart, and like the email on the hello you're logged in as, like, that.
Exactly.
So we can,
there's maybe like 1% or like 10% of content that's dynamic, but most of it is the same content for every user.
yeah. And so the way that we can think about this, I'm going to draw this really poorly, is like, if somebody's on their computer, right, and then they're saying like, please give me a web page, you're going to go to a server, right, and that server is going to say, all right, I need to get this page. So it goes and it gets the source code. That's maybe the best thing I've ever done. And then it's going to go get the data, right? That looks like a database. And then once it has the data, it's going to come back to the code, and it's going to actually compile that. And then that all goes back to the server, which finally goes back to the user. And so that's a lot of work that has to be done. And we're leaving things out. We're leaving out authentication. We're leaving out, like, if there is a caching layer, if there is a, some kind of chain of events, if there's other stuff that's happening, A/B testing, all of those things are additional hops that are going to happen in this chain of command that like, this is all just time, right?
Yeah.
So if we want to fix that,
this for every page, right? Even for the same user, anytime they browse a different URL, you're doing this every single time.
Exactly. And so one way that we can improve this is if we start looking at like, if we think about it as what work can we do ahead of time? Like, what work can we do once versus what work do we have to do every time? And then it starts to create a different story. And that's where we start looking at the Jamstack. And so the Jamstack is pretty exciting in this sense. Like, I think I've already drawn this graphic before. So rather than trying to come up with it on the spot, I'm going to just show this graphic. Let's see, it's down here. So this, let me zoom in a little. This is what I was just trying to draw. So you've got the browser has to go to the server has to go to the database or an API. All that has to go through a template, which then turns into static assets that get sent back to the browser. When we go to the Jamstack model, what we're able to do is, ahead of time, we have a build step where we know the pages that are going to exist. So we go to a server, and then from that server, the server goes to the database and the API, and it gets the templates. And then that generates a big folder of static assets. But because we know that those pages don't change between requests, the browser then says, I would like a page, and it immediately gets that static asset back. And so we're able to kind of preemptively say, well, we know that the account page, like, skeleton is always the same. We know that the marketing page is always the same no matter who's looking at it. We know that, like, the dashboard page or the marketplace pages, those are all going to be largely the same no matter who's looking at them. And we can generate all that ahead of time.
Another
So
example is documentation pages. They never
yes,
change.
yes. Um,
They should change. They never change.
yeah, yes, absolutely. Um, but so what I think is oh, actually, there's a good question in chat. Let me read this out loud. Um, so in a way, this is shifting some of the cost of computation from the company servers to the user's devices. Uh, I think I would disagree with that. I think that this other way here, where we've got the whole app is kind of like a single page app where everything is living in the client, um, that can. But what we're trying to get away from is we're trying to get away from doing duplicate work at all. Like if you use the Jamstack approach, what we're trying to get to is like, here is some HTML. It's not work. You're not gonna like download this and then do a bunch of processing on your device. You're just gonna download it and look at it. And that's what makes it so fast. If you look at like the average, 11D site or something, those just compile down to HTML and CSS for the most part. And that makes them really fast. Like let's like, if we look up at the 11D site, this is not being built by the browser. It's not being rendered by JavaScript. This is just HTML. If we look at the source, we can see like this that's here. This is what was generated, and this is what was stored on the browser. So we don't need to like. This is without. It's all compressed, so that's not going to be useful. But this code is what was generated, and this code is what we see. We're not building this at request time. We're not building it on the client side. This is just a static asset that we're downloading. It's the same as if I open up if I open up a text editor and type like H1 hello world, that's what it is. What it is. It's markup.
Yeah. Another way to think of it is that you're not doing the computation on your phone, but you're getting this asset from somebody who's already done this computation ahead of time on the server. So you're just getting that pre-built page for you.
Yeah, exactly that. And so when you look at this sort of thing, well, a follow up question. So the benefits of improved caching outweigh that. Sort of. I mean, caching is an extremely hard problem, right? So one of the things that I've run into is like at IBM, when we were trying to solve this problem originally, we were trying to solve it by like putting a varnish cache in front of a Redis cache, and then those would sit in front of like, so we had varnish in front of our rendered pages, and we had Redis in front of our databases, and it was trying to make all of that really, really fast, and it would work. And then it wouldn't. Like it would work, and then something would get out of sync, and then we had no idea why, and so we're like invalidating the cache, and it led to so many headaches and tangles that I don't think it was giving us the benefits that we were hoping for. Whereas with the Jamstack, what we're doing is eliminating pieces, we're eliminating moving parts, so that you're taking like a rendered asset and you're putting it on a content delivery network, and like if you're putting it on Netlify has a good CDN that's kind of a multi-cloud. It uses AWS and Azure and Google Cloud and all those. Or you can, put it up on Fastly. You can put it up on Akamai, whatever you want to use. All of those are very specially designed to heavily cache with very good invalidation, so that you don't end up with that situation where things are like disconnected. For that reason, this approach is going to be, I hesitate to say superior. I will say less prone to keep you up all night because you can't figure out what's wrong. And to me, like for what I'm optimizing for in my life, that is a superior approach. But yeah, so I guess Shruti, when you think about this, where does this start to break down? Like what do you see as being the challenges of this, especially at PayPal scale?
Yeah, so there's at PayPal scale, especially, right? There's like custom things we're doing in the node, the server for the web app that we created here. And what works well is that when a user navigates to a page, we can deliver that page to them. we can deliver the shell, and with the help of JavaScript, we can also make that page or that shell dynamic. And that works really well. So we can give this dynamic app uh, experience to the user. When it starts breaking is when we have these custom logic that we have for the purpose of logging, authentication, um, A/B testing. One of the things that I found really hard, and I still don't have a solution for that, is how are we going to do A/B testing in this approach?
So
And we do that in enterprises quite often. So that's a common use case as well.
So with something like A/B testing, there are ways to do that on the client side. With something like Optimizely has client side A/B testing, which in certain cases can be awesome. In other cases, it can be a performance drag. But like there are also Phil Hawksworth has some really good content on this. Let me see, what is Phil Hawksworth? If I can spell it, Hawksworth A/B testing. He has, here's one, some really good content on how to do this, where you're basically able, like Netlify is kind of built for this. You can just do it by setting up 2 branches and then setting what percentage of people you want to see each one, and it will handle the cookies and the session so that people see the same split based on what they're doing. So there are ways, like you can use Netlify for that specifically, but you can also do it through your CDN by setting some sessions and doing some routing that way, where you can basically look at somebody coming in and you can tag them and then use your routing layer to kind of proxy over, like /account. You would basically proxy /account, check for the cookie. If it has one, you would route them to the one associated with that, like account A or account B. And then if they don't have one, you would look at your percentages and assign them one or the other. And then like they get tagged with that. So it's very similar to the way you would do it on a server, but it is, it's, you know,
So
just
this is
kind of
inbuilt in Netlify?
so this particular feature, yeah, we have split testing built into Netlify, which is pretty fun. It makes it nice and easy. You just get 2 branches and you're like, I would like to see what these 2 branches look like side by side and test performance. And nice. So that part is really, really nice. But yeah, if you want to use, like, it's not a strictly Netlify thing. It's a thing that you can build in by working on your routing, basically.
So what I'm guessing is that it's probably picking a cookie from the browser, and as part of your API, you're sending that cookie over to whichever layer does the actual A/B testing for you. Is that right?
I can't remember exactly how it works, but we send something in the headers for the request that we can use to sort people properly.
Okay, so I think for our purpose, what we could do is we could pick that cookie from the HTML from the browser and send it over as part of our API. And then we have this inbuilt custom tooling that we use for A/B testing. And if that can pick up that cookie, then basically we're done. Then the middleware or the server can take care of the rest of the logic for us. I guess one thing to note here is that we'll have to still render some sort of shell for the user even before we kick in our A/B experience, something that is uniform.
So with that, you could go more toward a like a serverless functions approach. And with the serverless functions, it would be effectively the same thing. You're going to get a request in, and then those headers will come in so you can determine who somebody is. And then based on their header, you can send off a call to a serverless function and include that header with it, and just return back the different data. So you can effectively serve them an empty shell with like a skeleton state that says we're loading. And then based on what information goes back through the serverless function, you can return whichever side of the split test they're supposed to get, and render appropriately. And like there are some interesting client-side libraries that I've seen where you can conditionally load React components. So like, or any front-end framework component, where you're basically saying like, I don't want to load all of the code for all of my A/B tests. What I want to do instead is I want to check for feature flags. And if that feature flag is set, I'm going to conditionally load this particular component and that is the split test basically.
Hmm.
So
Well, cool.
this is one of those things where I think there are a lot of ways to solve that problem, and it's very much going to depend on exactly what you're trying to do. But I know I've seen it done at multiple scales. You know, we've got clients doing it in, you know, the completely client side realm. We've got people doing it solo based off of deploy branches, so that there's no JavaScript at all, and gradients in between. So there's ways to solve it for sure.
Cool. Awesome. And then another challenge I was thinking was in the enterprise level, we have all these microservices, right? So how do we pick which microservice should go first, or like which this front end should become Jamstack first?
Mm,
Um, and then one thing that I was actually talking to folks at PayPal was that Jamstack is not really like one specific technology, right? It's like this way of thinking, really, right? It's like
yes.
this way of best practices, which is so important, right? Often we think Jamstack is like we need to introduce Gatsby or we need to introduce like Netlify or something, but it's
Hmm.
really not that. It's a set of best practices we can do.
Yes. I mean, I actually would equate Jamstack closer to microservices than to a particular
Hmm.
tech stack, because it's a way of thinking about organizing things. And to me, the way that GraphQL creates this clean separation between data services and like the business logic or the front ends that are consuming that data, the Jamstack provides a similar clean separation between presentation and everything else. And you can kind of make your mind up about how you want to manage that everything else, because you could set it up as a node service that is all of your business logic, or you can set it up as serverless functions that just do like ad hoc things, and that can be whatever you choose. Like it really doesn't matter. Or you could set it up all up to be client side, and it just makes a call to your GraphQL layer directly, and you've got static assets
Yeah.
that asynchronously call GraphQL for the dynamic stuff. So but the thing that's important is not how you do it. It's that what you're doing is you're eliminating this need for a long running server. And the
Mhm.
reason for that is because we want to get away from the ability for someone to like DDoS our website. Um, and like the power of this really is like, do you remember when Popeyes launched that chicken sandwich and the internet like
Mhm.
lost its mind? Um,
Yeah.
so they built the Popeyes website is a Jamstack site. It's one of Netlify's customers, so which is why I know these things. But so they built their site as a Jamstack site, and even when the whole internet was trying to go to their site, they never had a service outage. Like they had that like front page of the internet effect where hundreds of thousands or millions of people are trying to look at this website at exactly the same time. And historically, it was like the best bad news you could get is that your site got so popular that it got taken down, right? Like, oh no, we're over capacity. Like, dang it, I guess we're so popular that you can't use our website right now. The Jamstack eliminates that problem. You because everything is served directly from a CDN, you can't overload a server and take it down. Like I'm sure that you can DDoS a CDN, but it is hard. It would take
Yeah.
a really serious effort to take down a CDN just by capacity. And so I think that's like that architecture. That's why you do it, and the how you do it, what stack you're using, those things don't matter as much. The important thing are the architectural decisions that mean the entire world can go to your website right now, and the infrastructure is not going to fall over because you've generated everything to a static asset, which means that there's no work to be done. It's just delivering a file.
Yeah. That's powerful, right?
Mm-hmm. Um, and so yeah, so I mean, like, kind of digging into that a little bit, because when you start talking about static assets, that potentially opens up this other thing, which is like, okay, well, if it's static, how do we do dynamic stuff? Like,
Mhm.
how do we get that user data? How do we make those extra calls?
And I think Jamstack actually addresses that question really well on their home, on their main website, which is I need to do dynamic stuff. How do I do it? I think it's on Jamstack's website itself.
Yeah, where is it? Is it in? I can't remember where this is. But there are some really good examples here on this website, which I just dropped in the chat. I can't remember where that exact thing is. It's somewhere.
Or was it on Gatsby?
So yeah, Gatsby is another resource. They've got a lot of good information, gatsbyjs.org, about how you can kind of do some of the dynamic stuff. A really common way to do that is we talked a little bit about the serverless functions thing. One of the reasons I like serverless functions is because it's like, you're going to need a server for dynamic stuff. I need to be able to send off a request that knows who the user is. And in order to do that, it has to be somewhat dynamic. It has to be listening. And I need to send like an auth token or an API key or something that says, hi, I'm a user. I have permission to see the thing that I'm asking for. And we can't statically generate that. Like that would be a security nightmare trying to figure out how to, generate millions of pages with people's personal information and store that. We shouldn't do that. So instead we can do, we could stand up like a node server, and that node server doesn't serve any files. It's just an API. And when I make requests to it, I'm going to say like, I want, this user's kind of what we were talking about before with microservices. I want the user information. Let me have that, please. Here's my authentication token. That's pretty cool, right? But the risk with that sort of thing is that you are you're letting someone know where the database is. And one of the big benefits of the Jamstack is it's really secure by default because there is no server. You can't hack the server of a Jamstack site. You can just deface the generated assets, which can be fixed by like you just upload it again. And it's like, okay, well, you're a jerk, but we changed that password and we re-uploaded the site and like, no harm, no foul. You didn't have access to the source code. You didn't have access to the data. Calling an API directly means that you are showing somebody where that data is. You're saying, oh, we do have like api.rsite.com. And if you go hammer on that, you might be able to get to the user data. If instead you use a serverless function, the serverless function is like mysite.com / API / give me data. And under the hood, that serverless function goes to your website, but that's never exposed to anybody. They can't find it in the network trace. They can't look at your source code because the serverless functions live somewhere else. And so you're able to kind of make a secret call, but that can still have the authentication. It can still use the API tokens, and it keeps all that out of client-side code. So if you need like an API key, that API key lives in the serverless function, and then your site has a user that sends an authorization token, and you can use those two things to say, all right, I have a logged in user, and this is a like authorized use of this API. So I'm going to send both of those things in. And then somebody can't just like take their JSON web token out of your client side and go hammer the endpoint to see if they can find like unlisted endpoints or something. So there's a little bit of security that way.
Yeah, that's exactly what I was going to ask. Where does the serverless function live?
Oh, thank you, Julie Strader. It's good to see you. Thank you for stopping by. So a serverless function is going to live in a number of places, right? So like Netlify has, it's kind of built in, like Netlify functions are, you just create a folder called functions in your site and Netlify will automatically deploy them. And then they'll kind of set up all the proxy and all that stuff. So like this is a Netlify function and it's, oh, that's kind of cool. You can do a split test thing, but you export a handler and then that handler returns a status code. And in between, it's a node app. So you can send off calls to other APIs, you can save things, you can touch databases, you can process things. And so that all just lives in this functions folder. And then we'll automatically deploy it and it would live at your site. By default, it's yoursite.com/.netlify/function/ the name of the function. But you can proxy that to be /API or something. And that can all be done like in one line of code. So what's really nice about this is it's effectively an abstraction over AWS Lambda. So AWS Lambda is one of the leading serverless providers where you do the same thing. You write a function like this and it's a handler. And then you would deploy it to AWS Lambda, and then you would need to kind of set up the routing for it through AWS. I think you would need like Route 53 and an API gateway, I believe. And then that's kind of your deployment pipeline. The serverless framework is good for you write a little bit of YAML and then it kind of automates the deployment. Azure has a function solution. Google Cloud has a function solution. I think all the major cloud providers have some support for serverless functions. And then there are some independent players as well that like you can go, like Netlify is kind of an abstraction over AWS Lambda. If you don't want to use AWS at all, there are some other companies that'll let you do serverless functions through their platform. But in general, like all of them are going to be a collection of JavaScript functions, or you can write them in Go. I think you can write in any language depending on which provider you use. I think Netlify supports JavaScript in Go. So you write your collection of functions, you figure out where you're going to deploy them, and then you basically just have this collection of endpoints. It's kind of like it's standing up a single REST endpoint at a time, effectively.
I see.
And then you can, if you want to, turn that into you can use GraphQL with it. You can use REST. You can use, direct database connections if you are into that sort of thing. Like you can do whatever you want. But it's
so the way your this flow would work is that from your HTML page you would call the serverless function, and the serverless function then figures out which API to call, and has access to the database through a API layer.
Yeah, so let me show really quickly. I'm actually, this is exciting that we're talking about this because I'm doing a front-end master's course on this tomorrow. So I have examples that I've been working on all week that I can show real quick. So this is a sneak preview of tomorrow's workshop. So this is like let's see, check out main. So this is what a serverless function looks like if you want to, say, load movies from, I'm using Hasura as a database. So I have a utility function that uses node fetch to send off a query to Hasura. So it just sends off my Hasura secret key to this Hasura GraphQL endpoint. It sends it as a post request. And then when it comes back, it just returns the data. And so I use that here to say, here's my GraphQL query. I want the data about the movies. And once I get that, then I make a call to the OMDB API and I pull in additional information. So I pull off the ratings, like their score from Metacritic and Rotten Tomatoes and stuff. And I combine all of that together and I return it. And so I'm able then in my front end to make a request to this data where, let's see, here it is. I make a fetch call to the function. So I make a call to this movies function, which is the one we were just looking at. And when I get it back, I just loop through and put this data into the container, right? And so I had this pulled up. I think I have this pulled up. Yeah, so this is, wait, is this it? This is the workshop. It's going to be live tomorrow if you want to watch it. And then this is what that page actually looks like. So it's pulling the movie data, and then this is the data from the OMDB, and it all gets assembled at runtime. So I'm loading it client side, but you could load this ahead of time if you wanted to. But that calls off to a serverless function, and then we get that data back, right? So
Batman versus Booperman.
Yeah. I also did these ones. Like I'm unreasonably proud of how much I put so much time into these. I'm very proud of myself.
Which one is your most popular movie?
I mean, this is my favorite, but I think the most popular movie was, I think this one's the best rated, In the Boop. Yeah, this one's got the best ratings. But yeah. So don't make fun of my B. I tried my best. I got close, right? But anyways, so all of that is powered by these serverless functions, and then you can do the same thing to like add movies. So part of what we'll do in this in this app is we'll have the ability to, I'm not going to log in. We'll have the ability to create new movies, and it's all protected by password stuff. So, we're able to pull in like that same Hasura utility to send off a mutation this time, and we create a new movie, but we're able to grab that data from the client side. We pull the user and check that they're an admin and make sure, and if they're not, then we can bounce them back and say like, no, you're not authorized to do this thing. And if they are authorized, then we let them do the thing and send it back. And like, this is the whole app. There's no other server running. There's no other thing. So it just consolidates it all down to like, I'm just writing logic, right? I'm not figuring out how to deploy this. It's just this folder, and I tell Netlify to deploy it. That's like all the config that I need to get my serverless functions up and running. And so it eliminates this enormous amount of overhead for me.
Yeah, so you move the business logic layer out into smaller functions, and they are deployed now like on AWS. Yeah, that's super handy, super cool, super nimble as well.
And that's what I like about it, right? Is that you're basically, each thing is this very controlled story. So instead of this sprawl where the logic kind of spreads out and gets its tendrils into like all these different UIs, and then you're depending on it for different things, like it's just one function, and each function is self-contained. So, outside of this shared utility, like, and you can make any architecture bad, right? Like you can, if you put an effort into it, you can make anything hard to maintain. But I think that the major benefit here is that because there's so little boilerplate, it's easier to keep things contextually grouped and separate enough that they're maintainable without needing like huge cross-team collaboration to maintain this stuff.
Yeah, and that's actually a very common use case as well, right? Like we'll have our front end form, and all we're doing is like we've rendered our form, we are letting the user fill out the data, and then we are collecting that data on our server layer and sending it over to the API. So now we have access to the API. We can use a serverless function to just deploy that piece of code, keep it very light as well.
Exactly. So that I think is like, this is why I think it's so exciting, because when you get into the enterprise, like the hardest part about building enterprise apps isn't, take this with a grain of salt. The hardest part for me is not building the software. It's keeping everybody who's working on the software aligned on how to build good software. Because it feels like most of the time that I spent wasn't on making the thing work. It was on trying to talk to everybody else to make sure that we weren't accidentally breaking each other's stuff. And I think that what's exciting about this approach is that it creates better boundaries between things so that it's less likely that I can accidentally break your code by making a change to mine. And I think that that's a really, really powerful thing, especially when you're starting to look at scale. Because, if the team that I'm collaborating with is in China, we've got an hour of overlap a day when we're both in the office. That's not really that's not going to work if we have to collaborate heavily. We need to be able to hand off and talk to each other, but not necessarily need to be like, all right, I'm going to flip this switch now, then you flip that switch, and then let's test this together. Like, we don't have time for that. We'll never get anything done.
Yeah. And because these are separate, right? Like I can't break your app if I deploy something.
Exactly. And the other thing that's nice about this too is like the Jamstack approach. Let's pull up like a site here. The thing that's really exciting about this is like, if we go in here and we accidentally break something, I can look at my deploys, and let's say this deploy is broken. I can click on this one and I can just roll it back. Like that will just move us back to the previous deploy. So, and it's instant. So if we accidentally break something, it's not like we have to go untangle the server code or like roll back databases or whatever. We're like, okay, well, let's just put the old one back. Let's figure out what went wrong, and then we'll redeploy again, and the fix will roll out. And so, that's not, it's very easy on Netlify, but it's not a Netlify specific thing. It's a Jamstack thing. If you are rendering to static assets, every deployment of your site is a folder. And so each deployment just creates a new folder. You just throw those folders up. And if you keep the last, whatever number of deploys on hand, if something goes wrong, you just flip back to the previous deploy and you're happy.
Yep.
Okay. So we've got like 5 minutes left. Were there any questions that you wanted to dig into that we didn't get a chance to?
Let's see. I have my list of handy questions here. So we talked about doing an A/B test. We talked about moving custom.
Thank you, chat.
We talked about moving custom middleware to the server layer, and those are the biggest two challenges I think that we face. One of the things that we're working on at PayPal as well is to make the deployment to CDN easier. And I know like Netlify does it really well. So tell me a little bit about how Netlify is moving assets to CDN with Git deployments.
So our process is kind of all built where when you push to Git, we listen for that event, and then we'll pull the changes, run the build command, and we have build plugins if you want to do like visual diffing or integration tests or something. And then once we get a success, we will upload to our CDN, and we do that like we have a multi-cloud CDN, so we've got a bunch of stuff in the background that's going on, but effectively we're just uploading the files. And once we upload the files, it gets a unique URL, which is based on the Git commit. So if let's look at one of these commits here. I have my production branch, but then I have like this older branch. And if I want to see this deploy, I can click preview. So this is the previous instance of this app that I built. And if I want to go to the live version, I can go to like the top level. This is the actual live site. And so we're able to kind of, each one is an independent thing. And then once we know that the upload is successful, we just route, like we update the routing to say, instead of production being this deploy, now make production this deploy. And so basically the sites are always kind of live unless you specifically take them down. And you're able to just kind of route between. So you can put that behind a firewall where like only the one that's production is actually visible outside the firewall. But that way all the sites are always there, and you can do really interesting comparisons. You could do like performance tracking over time. You can make sure that your sites are like actually faster and all those things. And it that's handled because you're building it to a folder. You're effectively uploading the folder to a CDN the same way that you used to drag a folder into your FTP client back in the 90s.
Right. Well, I've done it when I was just starting out 6-7 years ago. So not that long ago.
Yeah, I think
WordPress.
I did some WordPress stuff like in the like 2010-ish. We were still using FTP for that.
Exactly.
So it's definitely like, what I like about this is it feels as simple as when I was doing that sort of work, when I just had like a website in my FTP folder, and I would I'd drag the new files and then it would go live. And if I didn't like it, I would just drag different files and then that would go live. And this is the same idea. I push changes to Git, and whatever goes up to Git ends up live on the website. And you can put controls in place for that, but it's really, really like, I love the simplicity of that. It moves us back to this idea of like continuous deployment, and not continuous deployment because of this really elaborate DevOps process, but continuous deployment because all of those gates have been removed. You're able to just get something live.
Yeah.
I would love to keep talking about this all day because it's so much fun. So Shruti, if you don't mind, do you want to give us one more dev joke and then we'll get out of here?
I'll give you two.
Oh, all right.
Okay. What did JavaScript call his son?
I don't know. What did JavaScript call his son?
Jason.
That's topical.
Okay. This one I really like. What airline do developers prefer when they are in a rush?
What airline do developers prefer when they're in a rush? I don't know.
Does the chat have any guesses?
What do you think, chat? I don't think they do.
Delta. Okay, we'll do one more.
Okay. All right. One more.
How long does a loop last?
How long does a loop last?
For a while.
Oh god. Okay. Yeah, that was excellent. So, Shruti, always a pleasure having you on. Thank you so much for coming on and talking with me today. I really, really enjoyed this. Chat, you are able to, if you want, you can see our notes here. And we'll make sure that all the links that we shared today get published in the show notes. If this is your first time, thank you for coming and hanging out. Definitely go check out the schedule. We have a whole collection of amazing episodes coming up and a bunch that I haven't even had a chance to put on the schedule yet. But later this week, we've got David East coming on to teach us Firebase. This is going to be a whole ton of fun. Really want to see you there. So please, add it to Google Calendar, subscribe. We'll see you next time. Shruti, thank you so much for coming on today.
Thanks for having me, Jason. This was a lot of fun. I love the boops.
I too love the boops. Thank you, chat, for burying us in boops. One more shout out to our sponsors, Whitecoat Captioning for doing the live captioning, and Netlify, Fauna, Sanity, and Auth0 for making the live captioning possible. Y'all are amazing. Thank you very much. Chat, stay tuned. We're going to raid. I'm still here. Hello. Okay, so we'll see you next time. Thanks, everybody.